So today we are working on pages 7 through 15, starting with question number 15. Okay, so in this question it is asking us, is the transformation above a single reflection? Justify your answer. So we can reflect across the x-axis or we can reflect across the y-axis. In this case, we are reflecting it across the x-axis. So to answer this question, the answer would be yes. The transformation is a single reflection. Yes, it is a single reflection across the x-axis. Oops. Now if we look at the different points, the point for A, the coordinates are 2, 4, and the coordinates for A prime are 2, -4. So you can see when we reflect across the x-axis, it actually switches the y coordinate. So our rule for that would be that xy becomes x negative y. Okay, in B it says, is the transformation above a translation? And the answer to this question is no, and the reason for this is because in a translation we're simply moving the shape, and there's no translation we could do in order to move this where we would want to move it to. So for instance, A, you would have to move down 8 units, but for B you would only be moving down 4 units. So we would write no, and something along the lines of points A, B, and C do not translate to A prime, B prime, and C prime. For part C, it says determine a transformation with 3 reflections that will produce triangle A prime, B prime, C prime. Now there's multiple, I guess there's actually only one way we could do this. So first thing we're going to do is we're actually going to reflect it across the y-axis, and if we do that, it would translate over here, and we would have a shape that looked like this. This would be one reflection. And then if we reflected it across the x-axis, it would reflect to these points. And then finally, if we reflected it, if we reflect it back across the y-axis, it would end up with our final image here. So in this case, we would say the first transformation, I'm going to move this down a little bit. First translation would be, it's going to be reflect across the y-axis first, then reflect across the x-axis, then reflect back across the y-axis. Okay, moving on to the next problem. Problem number 16 says if figure ABCD is congruent to figure EFGH, write all 8 side and angle congruent statements. Okay, I think it helps to draw a picture here. ABCD has 4 letters, so that's going to make it a 4-sided figure or a quadrilateral. So we're going to draw any type of quadrilateral here. Since it's congruent, we want to draw a congruent quadrilateral over here. And on this one we're going to write A, B, C, D going around this way. And it's congruent to E, F, G, H. and we're writing this, a couple things that we want to note. Number one, it doesn't matter where we start with A. I just picked the bottom left. You could start at any point, but you do have to follow this order going around. So A, B, C, D. We could not do A, B, and then put C down here and D up here. That would be incorrect. And the second thing is, since the figures are congruent, wherever we start here, we want to start the same place here. So since this one started with A and this one starts with E, since I put A on the bottom left, I'm also going to put E on the bottom left. Alright, now we want to write our side and angle congruent statements. So first of all, matching up the angles, we have that angle A is going to be congruent to angle E. Second, we're going to have that angle B is congruent to angle F. Third, we're going to have that angle C is congruent to angle G. And finally, we have that angle D is congruent to angle H. So that takes care of our 4 angle congruences. Next, we want to write the 4 side congruences. So let's again just start with the first side. We have side AB, so we're going to put side AB is congruent to side EF. Next, we are going to have side BC is congruent to side FG. Next, we have side CD is congruent to side GH. And finally, we have side DA, DA, congruent to side HE. Okay, moving on to problem number 17. It says if all corresponding sides of 2 figures are congruent and all corresponding angles of the 2 figures are congruent, then the figures must be, well, if the sides are congruent and the angles are congruent, then the figures themselves must be congruent. Alright, moving on to problem number 18. Looks like 17 is still at the top of the page there, so we're going to move that up. Okay. This says, in the figure below, point S is the midpoint of WU. So the first keyword there is midpoint. Remember, midpoint means that the point is in the middle. And because it's a midpoint, that means that this segment right here and this segment right here are going to be congruent to each other. And it tells us that right here. Therefore, WS is congruent to US. You wish to prove that the 2 triangles are congruent. To prove this congruence by side, 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 what 2 additional congruent statements are needed? Well, if we want to prove this one by side, 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 we're going to use different colors because there's 4 different problems. We'll use 4 different colors. So first, let's start with green. So for this one, the extra information we're going to need is we're going to need to know that these 2 sides are the same, and we're going to need to know that these 2 sides are the same. And if we have all 3 sides here and all 3 sides here, then we know that that the triangles are congruent by side, side, side. So let's write that down. We need to know, in order to prove this, we need to know that WR is congruent to UT, and we need to know that RS is congruent to TS. Okay, moving on to number 19. For number 19, let's pick a different color. So we're going to go with light blue this time. This time we're using side, angle, side. So it says, what 2 additional congruent statements are needed? So again, we have our given statement, which is in red. We want to use side, angle, side. So side, angle, side, the angle is included between the 2 sides. So we're going to need to know the sides. We need to have a given angle, and we need to have another given side. So I'm going to use this angle right here, and this angle right here, and then I'm going to use this side over here, and this side over here. So again, we're using the red given information and then the blue sides that we marked. So in this case, we need to know that angle W is congruent to angle U, and we need to know that side WR is once again congruent to side UT. Now this would not be the only possible way to prove side angle side. We could have also used sides 1 and 3 up here along with this angle WSR, and side 1 and 3 over here with angle UST. So there's more than one way to do this. Alright, for number 20, let's pick a different color again. This time we're going to go with this purple color. And this time we want to use angle side angle. So to prove this congruent by angle side angle, what two additional congruent statements are needed? So again, we have the given information, which are the red sides. We need angle side angle. So the side has to be included and in between the two angles. So we're going to use this angle again, U and W. And then we also have to have the other angles have to be included, which are these. Now, a common mistake is to just name these angles as angle S, but we can't name them angle S because S could be any of these three different angles. And so if we just said angle S, we don't know which angle we're talking about. So we're going to use three letters in order to name those angles. Now for W and U, there's only one possibility each, so we can use one letter for that one. So we're going to write W, angle W is congruent to angle U, and angle WSR is congruent to angle UST. Alright, finally we have 21, so we're going to choose the orange pen for this one, and this time we want to use angle angle side. So similar to the last one, except that the side is not the included side, and so once again we're going to choose our angles W and U. We're going to use that angle, and then we want to use the other angle that's not included, which would be this angle up at the top, and we're going to mark that angle R and angle T. So now you can see we have two angles and the side that's not included, two angles and the side that's not included. So those angles, again, we're going to have angle W congruent to angle U, and we also need to have angle R congruent to angle T. Okay, moving right along. So on to problem number 22. State two additional congruent statements that will be insufficient to prove the triangle is congruent. Okay, and so in this case, I think this is a continuation of the last problem. Two additional congruent statements will be insufficient to prove the triangle is congruent. Alright, well one, if we look at our triangle congruences, the ones that work were the ones that we were just talking about, which are side, 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 angle, side, angle, side, angle, and angle, angle, side. There's also hypotenuse leg, which only applies to right triangles. The ones that, so these are all good. Yes, these all work. The ones that do not work are angle, 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 and side, side, angle. Those are not enough information to prove that the triangles are congruent. Now, since they already gave us a side, we can't end up with angle, angle, angle. So the question is, are there any ways that we can end up with side, side, angle? So if we look back at our picture again, in order to get side, side, angle, we could either have the red side and the blue side and then not the included angle, or we could have the red side and the green side and not the included angle. Alright, and so if we write those down, the two pieces of information is we could have something along the lines of, looks like RW congruent to TU, and then also angle R congruent to angle T. And if we had that along with our original information, that would give us side, side, angle. Let's take that picture and transpose it over to this page. So I'm going to pause for 1 second while I get that information. Okay, So we've now added the picture back in here, and this will make it a little bit clearer, I hope. So if we take a look again, we said because we already have a side, we can rule out angle, angle, angle as the possibility. So we're looking for examples of side-side angle that are, because again, side-side angle is insufficient to prove congruence. So side-side angle, we have this given side, so what we just wrote down was RW, which is over here, congruent to TU, and angle R congruent to angle T. So again, that would make it so that we have two sides and the angle that's not in between them, which would be side-side angle, and side-side angle is not a sufficient way to prove that triangles are congruent. Since it wants two congruent state two additional congruent statements, so these are our two additional congruent statements. And so there'd be other ways to do it as well, but that's one example. If instead of side RW, another way we could do it is we could use side RS and side congruent to side TS, and we would still have sides or angle R congruent to angle T, and this would still be an insufficient way of proving it, because basically what would happen is these two sides would not be there, but we'd be marking this side congruent to this side, and again we have side-side angle where the angle is not included. So that's just two examples, and there may be some other examples as well. Okay, moving on to problem number 23. It says Consuela wants to determine the length of a power line that we stretched over the lake. She cannot walk through the lake. She was able to take some measurements, hoping to determine the length. Her measurements are shown below. Now, a good thing to note here is it says figure is not drawn to scale, and that's actually the case in a lot of these drawings. But so when we take a look, what we should notice is that we do have two triangles here. We have 450 feet here and 450 feet here, and then we have 500 feet here and 500 feet here. So right off the bat, we see that there's two sides and two sides that are congruent to each other, and so we may be thinking along the lines that the two triangles should be congruent to each other. Now this says Consuela believes the length of the power line is 625 feet. She's not sure how to explain this to her boss. So she thinks this is 625 feet down here at the bottom, but she's not sure why. And so, using what you know about triangle congruence, help Consuela by writing a brief report as to why the length of the power line is 625 feet. So essentially what we're trying to do is we're trying to use a triangle congruence proof here to prove that this power line should be 625 feet. And they want you to write it out as a brief report. So the first thing is we've noted that the different sides are the same, and if you look at these, whenever we have two angles that meet at a point, then what's going to happen is we're going to have vertical angles that are formed, and so these vertical angles are going to be congruent to each other, and because we have two sides and an angle, this should be an example of being congruent because of side, angle, side. Alright. And if we know that the two triangles are congruent, then all of the parts of the triangle match up, and our reasoning for that was CPCTC, which again stands for corresponding parts of congruent triangles are congruent. So when we write our brief report, we want to include these different things. And so we'd want to say something along the lines of the given sides of 450 feet and 500 feet are congruent. The vertical angles are also congruent. Therefore, the triangles are congruent. side angle side in the top and, sorry, let me erase that. Let's just rewrite that. Okay. Therefore, the triangles are congruent by side angle side, and the top and bottom sides are congruent by CPCTC. So again, we would want to write something along the lines of that in our report. And so again, we want to mention the fact that there's two pairs of congruent sides. There's a pair of, pair of vertical angles, and that makes the triangles congruent by side angle side. Once the triangles are congruent, all the corresponding parts in the triangle match up. Therefore, the top side of 625 is going to match the bottom side of 625. Okay, moving along to problem number 24. In problem number 24, it says, state whether the triangles can be proven congruent by angle, side, 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 angle, side, or side, angle, side. If the triangles cannot be proven congruent, state why. So again, the four they gave us are all going to work. The ones that do not work are, so again, these are good. These are the ones we're trying to prove. If we end up with side, side, angle, or angle, 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 those are the ones that do not work. Okay, so for each one we're going to mark the triangles congruent, and then we'll go from there. Alright, so let's start with number 24. So we have AB is congruent to FE, AC is congruent to FD, and angle A is congruent to angle F. So we have two sides and an angle, so it could either be side angle side or it could be side side angle. So the question you have to ask yourself is whether or not the angle is included or if it's not included. And so in this case, because the two sides are used to make up the angle, it is the included angle, and these two are congruent by side angle side. Alright. State whether the triangles, okay, so this would be yes, they are congruent by side angle side. Just so that we're not confused, we're going to go back up and erase the triangles as we do each problem. Alright, for number 25, we're going to start with angle A, congruent to angle F. We're going to have angle B, congruent to angle E. And we're going to have angle C, congruent to angle D. And so when we have three angles in one and three angles in another, that does mean that the triangles are similar, but it does not guarantee that they are congruent. And so one example you can think of is when you have two equilateral triangles. In an equilateral triangle, the angles are all 60 degrees, but all equilateral triangles are not congruent. For instance, an equilateral triangle might have sides of 4, 4, and 4, and another one might have sides of 10, 10, and 10. The triangles are not congruent, even though the angles are the same. So in this case, we would write no, angle, angle, angle does not, sorry about that. Angle, angle, angle does not prove congruence. Alright, let's erase our picture again. And if we go on to problem number 26, we're going to mark angle A congruent to angle F. We're going to mark angle B congruent to angle E. And we're going to have side AB congruent to side EF. And so this time we have two angles in a side. That could be angle side angle or angle angle side, which both work. The question is the side included or is it not included? And in this case it is included, and so because it's in between the two angles. So in this case we'd say yes by angle, side, angle. Okay, once again, going back to the triangles, we're going to erase them and take a look at number 27. So in 27 we have AB congruent to FE, AC congruent to FD, and BC congruent to ED. In this case we have 3 sides in one and 3 sides in the other, so that is yes by side, side, side. Now when you're doing these problems, it's very important that you mark the triangle accurately and that you take time to actually mark the triangles. I know when we were working on these problems, some people were getting them wrong and they were marking nothing on the pictures. It's much, much, much easier to do these problems if you can look at it visually. Okay, let's erase our triangle one more time. And here we have angle B congruent to angle E. We have side AC congruent to side FD. And we have side BC congruent to side ED. So again, we have 2 sides in an angle, so the question is it side, angle, side again, or is it side, side, angle? So the question again we're asking ourselves is the angle included between the 2 sides, or is it not included? In this case, the angle is not included, and so this one we would say no, and again the reason is that side, side, angle does not prove congruence. Okay, finally for number 29, let's erase our triangle once again. And when we do this, we're going to have angle A congruent to angle F. We're going to have side AB congruent to side FE. We're going to have angle C congruent to angle D. And so again, if we look, we have 2 angles marked and 1 side. So it could be angle, side, angle, or angle, angle, side. So once again, it is going to work, just the question is whether the side is in between the 2 angles or not. So this time, the side is not included in between the 2 angles, and so in this case it's actually going to be yes by angle, angle, side. Alright, that takes us to the end of problem 29, and we're going to move on to the next one, which is 30. Alright, if you are following along, we are now at the top of page 11. This video will take us to the end of page 13. Okay, so for problem number 30, it says every quadrilateral that is a parallelogram has certain properties. And so it says list all these properties. So we want to list them out. And so the first thing it may help us to do is to actually draw a parallelogram. So I'm going to draw one of those out. And just to make it easier on ourselves, we're going to try to make it an accurate drawing, at least somewhat accurate. And if we draw this out, that hopefully looks pretty close to being a parallelogram. Didn't do a very good job on that last side. Let's try that one more time. Okay, so sketch a parallelogram. And the different properties that we're talking about is we want to talk about the sides, we want to talk about the angles, and we want to talk about the diagonals. Alright, and so in this particular case, the first thing we want to write down is talking about the sides. So what do we know about these sides? Well, first of all, it's a parallelogram, and so one thing that has to be true is that the opposite sides have to be parallel, and at the same time they're also going to be the same length as each other, so they need to be congruent. So our first bullet point that we're going to put down is we're going to write that the opposite sides are parallel and congruent. And that is true of every parallelogram. Alright, our second bullet point that we're going to make is that about the opposite angles. And so the opposite angles, this angle matches this angle, and this angle right here matches this angle right here. So we're going to say the opposite angles are congruent. Alright, the third thing that we want to mention talks about the diagonals. And so if we look at the diagonals, I'm going to pick a different color this time. If I draw the diagonals in here, just from looking at these, you can tell the diagonals are not the same. This diagonal is definitely shorter than that diagonal. And so the diagonals are not the same length, but what do the diagonals do? Well, the diagonals cut each other in half. So this diagonal bisects that one, and vice versa. Alright, and so let's write that out. So our third bullet point is that diagonals bisect each other. Okay. Last thing, going back to the angles, probably should have put this in third, but we'll put it in fourth, that's okay. The opposite angles were congruent to each other. What about the angles that are next to each other? Well, in a quadrilateral, there's always 360 degrees in all quadrilaterals. And so, since two of them are equal and the other two are equal, the ones that are next to each other are not congruent to each other, but they do add up to 180 degrees. And when they add up to 180 degrees, we call that supplementary. Alright, and so what we would want to write on this one is that we're going to call these consecutive angles. So consecutive angles are supplementary. Again, supplementary means they add up to 180 degrees. Alright, so that should cover all of our properties of parallelograms. Okay, what properties does a rectangle have in addition to those of a parallelogram? So a rectangle is a type of parallelogram, and a rectangle, as hopefully we all know, looks something like this. And so let's think about some of these things. So again, the opposite sides are still parallel and congruent. The opposite angles are still congruent, except these angles are special because these angles are now all 90 degrees. So that's something that we're going to want to include. Also, the diagonals still bisect each other, except now instead of one diagonal being shorter and one being longer, the diagonals are actually going to be the same length. And if you take a look, we draw these diagonals in, you can see how they are the same length. Alright, and so the things that we want to add in here are going, let me take that off. Things we're going to add in here, our first bullet point is going to be that the diagonals are congruent. Okay. And the second thing, let me clean that up a little bit. Diagonals are congruent. And the second thing is going to be that the angles are all right angles. Okay, finally, number 32, what properties does a square have in addition to those of a rectangle? So again, it has all these properties that we've already listed before, except now we want to add on to those. So again, we're looking at a square, and so for a square, here again is our square. First of all, the opposite sides are still parallel and congruent. The opposite angles are still congruent. The diagonals still bisect each other. The consecutive angles are still supplementary. The diagonals are all going to be congruent, and the angles are all right angles. So what other things can we add on here? Well, with a square, not only are the opposite sides congruent, but actually all the sides are congruent. Alright, and so we would want to write all sides Okay. The other things we want to look at are what happens with the diagonals here. And so let's draw those in. And so if we take a look, number one, they are actually going to bisect the angles. All right. So, oops, sorry. The diagonals bisect the angles. And then the other thing about it, if you notice, is that these form a right angle. And so the diagonals are perpendicular. Now these two facts are not true in rectangles, but they are true in squares. Alright, so again, if you look at these two diagonals, they definitely do not form right angles, and they do not bisect the angles. Okay, so those are our properties of quadrilaterals. Alright, going on to number 33. It says triangle DEF is isosceles with angle D congruent to angle E. So again, an isosceles triangle means that we have two congruent angles. Which sides are congruent? So let's draw out a picture here. And I'm going to draw our bottom side here. And then we're going to take this and draw it going up this way. And we're going to draw it going this way. Alright, so in our triangle, we have, it says angle D is congruent to angle E. So we're going to label these D and E. And that makes F right here, because it tells us that it's triangle DEF. It says these angles are congruent. Which sides are congruent? Well, the opposite, in an isosceles triangle, the congruent sides are across from the congruent angles. So if these angles are congruent, that makes this side and this side congruent to each other. So in this case, side DF is going to be congruent to side EF. Okay? Again, drawing the picture is going to help us immensely in this picture. Alright, number 34. In the figure to the right, D is the midpoint of AB. So once again, we have midpoint, D is the midpoint of AB. D is the midpoint of AB. Midpoint means divides it in half. So these two have to be the same as each other. E is the midpoint of AC, meaning these two have to be congruent to each other. Alright, because we are connecting two midpoints, the segment in the middle here is what we call a mid-segment. Okay, and so when it says determine the values of x, y, and z. So since we mark these two congruent, if this side is 10, then z here has to be 10. Also, since this side is split in half, if this side is 12, then x has to be equal to 12. And then finally, the last side, this is 22. Because this is a mid-segment, then that makes it half as long. First of all, it's going to be parallel to the base. And second of all, it's going to be half as long as the base. So in this case, y would be half of 22, which would equal 11. So if we write those out, we would have that x is equal to 12, y is equal to 11, and z is equal to 10. Now again, this only works if we're connecting the midpoints, and in this case we are. Alright, let's take a look at problem number 35. Alright, once again it tells us that D is the midpoint of AB, and E is the midpoint of AC. So once again, very similarly, we're going to mark these two the same, we want to mark these two the same. Again, every time we do one of these problems, we want to mark the information that we know, and then go from there. Alright, complete the statements using the items in the box on the right. So it gives us these items over here. Each item may be used more than once or not at all. So the first one says AD is congruent to what? Well, we already marked it. It should be congruent to BD. Second, AE, which we marked, is congruent to what? So again, and again, we're not going to cross these out because we might use them again. Again, it says that they can be used more than once, or they might not be used at all. But we had BD, now we're using AE. That should be congruent to EC. All right, next, blank is parallel to blank. Well, if they're mid-segments, that makes this side and this side parallel to each other. So again, we're going to do line segment DE, and we're going to make that is parallel to line segment BC. Now, if you take a look, D appears to be a repeat of A, except there's no line segment written over it. Instead of congruent, we have the equal symbol. So what that means is here it's really about the notation. So here we're saying side AD is congruent to side BD. Down here we're talking about the length of AD is equal to the length of what? And so in this case, again, it's still going to be BD, but we're going to write it as BD. So again, if AD was 8 units, then BD would also be 8 units. So those side lengths are equal, whereas the two, when we write them out as line segments, we would say the two line segments are congruent to each other. All right, similarly, AE, the length of AE is equal to the length of EC. Okay. All right, for letter F, we're saying blank is equal to 2 times blank. Well, there's two possibilities here. Actually, that's not, well, there's actually 3 possibilities. So the first possibility is that this whole line segment is equal to 2 times either one of those two. It could say this whole line segment A to C is equal to 2 times either one of those. Or we could say that the mid segment is equal to 2 times the bottom. Sorry, the other way around. The bottom is equal to 2 times the mid segment. And so in this case, we are just going to plug in the letters here once again. In this case, if we use the mid segment in the base, which is actually drawn on the top here, the base, which is BC, the length of the base is equal to 2 times the length of the mid segment, which is DE. Again, we're not putting the line segments over these because they're lengths. So the length from B to C is equal to 2 times the length from D to E. All right, the ratio of AB, which is the whole left side, to AD is what? Well, again, if we just look at the box, our choices are either 2 to 1 or 1 to 2. So AB is twice as long as it is from A to D, so the ratio for this one would be 2 to 1. And for the other side, the ratio from A to E is half as much as the whole side, so the ratio is going to be from 1 to 2. All right, if we take a look at problem number 36, it says, if 2 parallel lines are cut by a transversal, which angle pairs are congruent, which angle pairs are supplementary? So I think they want us to name those. It doesn't actually give us a picture in this one. There is a picture in the next problem, problem number 37, which we can use that to help us, but I think it may be more helpful to just draw our own picture. So let's draw our own picture next to number 36. So we're going to draw 2 lines that are parallel, and they're going to be cut by a transversal. All right, and so which angle pairs are congruent? Well, if we number these angles, just to give us, again, you don't necessarily have to do this, but 1, 2, 3, 4, 5, 6, 7, and 8. We should have 4 angles that are equal to each other, and then another 4 that are equal to each other. So if I take my highlighter, the green angles 1, 4, 5, and 8 are all going to be congruent. And then the yellow angles 2, 3, 6, and 7 are also going to be congruent. And so when we look at this, we would say, first of all, which angle pairs are congruent? Well, 1 and 4 are congruent. What kind of angles are those? So those are what we call vertical angles. So we have those that are congruent. We also have 1 and 5. 1 and 5 are what we call corresponding angles because they are in the same position. In these 4 angles, 1 is on the top left, 5 is on the top left for these 4 angles. So those are called corresponding angles. Okay, next we have angles 1 and 8 are congruent. Those are what we call, since they're on the outside of the parallel lines, and they're on opposite sides, we call them alternate exterior, because again they're on the outside of the parallel lines. And then finally 4 and 5 are congruent, and those are alternate interior angles. Again, drawing a picture here makes it a lot easier, I think, to think about all the different types of angles that are going to be congruent here. Let me just double check and make sure we have 1, 2, 3, 4. Yes, so we have all 4 of those. All right, let's take a look at B. Which angle pairs are supplementary? So again, supplementary means they add up to 180 degrees. So 1 and 2, going back real quick to A, I'm sorry. The yellow angles also make up the same type of angles. So like 2 and 3 are vertical angles, so they're congruent. 2 and 6 are corresponding angles. 2 and 7 are alternate exterior. 3 and 6 are alternate interior. So you have the same types of angles, whether you're looking at the green or the yellow. Okay, which angle pairs are supplementary? So again, we have 1 and 2 are supplementary. Because they're next to each other and they form together, they form a straight line. That is what we call a linear pair. So linear pairs are supplementary. Also, if we look inside, we have angles 4 and 6 are going to add up to 180 degrees. Because they're on the inside, but they're on the same side of the transversal, we call those same side interior. And if we take a look at angles 2 and 8, those are also supplementary, and those are what we call same side exterior. And really, in our drawing, any angles that are green added with any angle that's yellow is going to be supplementary. All right. And these are the 3 different types. So again, there's lots of different examples of those. Like for instance, linear pair could be 1 and 2, or it could be 1 and 3, or it could be 3 and 4, so on and so forth. Same side interior, we used 4 and 6, but it could have also been 3 and 5. Same side exterior, we did 2 and 8, but we also could have done 1 and 7. So there's more than one possibility for these. One thing you can remember is since they are supplementary, which starts with the letter S, all of the same side angles are also going to be supplementary. So same side interior, same side exterior, same side are always supplementary. The alternate exterior, alternate interior are always congruent. Okay, and then finally, if we take a look at number 37, 37 is a proof involving the same types of angles. And so if we take a look at the given information, it says angle M is congruent to angle N, so we're going to mark that. Those 2 are parallel. Angle 1 is congruent to angle 16. Alright, so that information is given to us. Everything else we need to use, and then we're trying to prove that P and Q are parallel to each other. And so the way we want to prove this is we want to find one of those types of angles that are congruent that we just talked about in P and Q, that then we can use that to prove they're parallel. Alright, we're going to do a 2-column proof for this one. Alright, so once we have this set up, we're going to start with our first piece of given information. So we know that side M is parallel to side N. Let's call that number 1. And the reason for that one is that it is given. From that information, well, because M and N are parallel, what angles do we know have to be the same? Well, if we take a look, 1 and 9 are going to be the same because those are corresponding angles. So let's write that next because we used the first piece of information to get that. So we're going to write angle 1 is congruent to angle 9. Oops. Didn't mean to write a P there. Sorry about that. Angle 1 is congruent to angle 9, and the reason is because those are corresponding angles. Alright, the next thing is we know that angle 1 is congruent to angle 16, and that is because that information is given to us. And actually, we're going to come back to that one in just a second. Before we do that, let's take a look at angle 9 and angle 12. So angle 9 and 12 are going to be equal to each other, and that is because those are vertical angles. So next we're going to write angle 9 congruent to angle 12, and that's because they are vertical angles. Next, we're going to write our other piece of given information, which is that angle 1 is congruent to angle 16, and that's given. And if you listed the order here, as long as you have the stuff listed, the order isn't necessarily, you know, if you put angle 1 congruent to angle 16 as the second statement, that would be fine. Okay, and so what we're trying to get at is that if 1 is congruent to 9 and 9 is congruent to 12, and 1 is congruent to 16, then what can we say? Well, 1's congruent to 16, and 1's congruent to 9, and 9's congruent to 12. So hopefully what we're trying to get at is that the two angles are going to be equal to each other. So first of all, let's start with angle 1 and angle 12. So from these two information, and maybe we should have actually written this as step number 4. I think that would actually, well, that's okay. We're just going to leave it the way that's written. But based on these two statements right here, we have 1's congruent to 9 and 9 is congruent to 12. So what that should indicate to us is that angle 1 is congruent to angle 12. And when we do that, that is what we call the transitive property. So for number 5, we're going to write transitive property. Now ultimately what we're trying to do is to prove that 12 and 16 are congruent, because just like in number 2, those are corresponding angles. So if 2 and 16 are congruent, then they're corresponding. If they're congruent and they're corresponding, then that makes the two lines parallel, which is what we're trying to prove. So we're almost done here. So again, we knew that 1 was equal to 9 and 9 was equal to 12. That made 1 equal to 12. So that's transitive. Now we're going to do the same thing here with this. 1 is congruent to 16 and 1 is congruent to 12. So what does that mean about 12 and 16? They're congruent to each other. So we're going to write angle 16 is congruent to angle 12. And once again, that's going to be because of the transitive property. If you take a look at the answers to the review packet from the county, you may also see this written as substitution. And so if you wrote substitution instead of transitive property, that would also be okay, because we're substituting in, for instance, angle 9 is congruent to angle 12, so we're substituting in angle 12 for angle 9. When we did this in class, I believe we called it the transitive property. Okay, and then finally, now that we know that 16 and 12 are congruent, now we should be able to prove that P is parallel to Q. And the reason for that is that if two lines cut by transversal so that corresponding angles are congruent, then the lines are parallel. So how do we want to write that? We're going to write if corresponding angles are congruent, then the lines are parallel. When we use the opposite to prove something, that's what we call the converse. So really we know that corresponding angles are, if the lines are parallel, then the corresponding angles are congruent. Here we're saying because the corresponding angles are congruent, the lines have to be parallel. Okay, finally moving on, this will be our last problem, problem number 38 on this video. and we are once again doing a proof. Now, the last proof dealt with parallel lines and the properties of parallel lines. This is a proof involving triangle congruence. Okay, and so once again, let's see if we can mark. We'll sort of make some notes to ourselves, and then we'll write out the proof. So the first thing we're going to do is that we have angle A is congruent to angle D. The second thing is that AB is congruent to side DE. And then finally, we want to look and see, again, once again, our choices to prove triangle congruence are side, 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 angle, angle, and side, angle, angle. Or I guess we wrote that as angle, angle, side, I'm sorry. And so for these four, we're trying to decide which one this could be. And so when we take a look, what other piece of information do we have? So sometimes we might have reflexive property, we have the same side or same angle congruent to itself. In this case, another thing to look for are vertical angles. And in this case, because we have two lines that intersect, we do have vertical angles. So these two angles are congruent, making this an angle, angle, side triangle congruence. Alright, so that's ultimately what we're trying to prove is angle, angle, side. And then once we know that the triangles are congruent, then we know that these two are going to be congruent because of CPCTC. Again, if the triangles are congruent, then the corresponding parts are going to be congruent. Again, this stands for corresponding parts of congruent triangles are congruent. Alright, so that's sort of laid out for us. Now let's see if we can write it out. So once again, we're going to write our statements, and we're going to write our reasons. If you want to write it as a flowchart proof, you could also do that. We're going to write this one as a two-column proof. Okay, so our first statement is just going to be our first given statement. We have angle A is congruent to angle D, and the reason is that it is given. The second thing I'm going to write down is that we have these two vertical angles that are congruent. Again, we can't say angle C is congruent to angle C, because C could be any of these four angles right here. So we're going to use three letters to define that. So for number 2, we're going to write angle ACB is congruent to angle DCE. And again, the reason for that is that they are vertical angles. Now, again, as we're thinking of this, we're trying to get to angle, angle, side. So I have my first angle, my second angle, now I need my side. So the side is the given side, AB congruent to side DE. And again, the reason for that, once again, is given. And again, if you want to write the given statements out together, you know, like in the first two steps, that's fine. I wrote it this way so that now I can see I have my angle, and I have my side, and so that's how I'm going to get to prove the triangle is congruent by angle, angle, side. Once we have all three of our angles and sides marked, now we know the two triangles are congruent. So I'm going to say triangle BAC is congruent to triangle, and so again, B matches up with E, A matches up with D, so we're going to do EDC, and again, the reason here is angle, angle, side. And again, once we have the two triangles congruent, then because of CPCTC, we know the corresponding parts are congruent. So in this one, I would say side CE is congruent to side CB, and the reason is CPCTC. Alright, that takes us to the end of page 13, which is where this video will stop. So thank you for tuning in, and best of luck on your exams.